Today I'm going to go over the Unit 6, Sections 1 through 2 notes. First of all, we're going to go over a little bit of a warm-up and make sure that we understand what some of the terms are that we're going to use and see what you guys remember from prior years. So our first question here is, what is a ratio? So think in your head, what is a ratio? You could pause the video at this point, think about it. Basically, what a ratio is when we compare two numbers. It's a relationship between two numbers, like males to females. Now, there are three ways to express a ratio. Again, you might want to pause the video for just a second and think about what those three ways are. And you guys learned these somewhere between 5th and 6th grade. So these are the three ways. 3-to-1 with the word 2, or 3:1, or 3/1. Now the order matters here, okay? Now, the third question here is, what does a proportion relate to in a ratio? Proportions have a relationship with ratios, and this is what that relationship is. A proportion is when two ratios are set equal to each other. So, for example, I have 5 children, and I have 4 boys and 1 girl. So the ratio of boys to girls in my family is 4-to-1. If I were to tell you that my family, my extended family, has the same ratio, 4-to-1, and I tell you that there are 80 boys and how many girls are there, then this is how we would set that up. Now, some of y'all remember these types of problems because we have this butterfly method that I know that a lot of y'all learned. Excuse me, right here. Butterfly method, my bad. So here we would do 4g is equal to 1 times 80. So we would get 4g equals 80. So the girls, which represents g, are 20. So if that ratio of 4-to-1 was the same, then in the family had 80 boys, then we would also have 20 girls. So that is how we deal with proportions. Proportions are when we set two ratios equal to each other, and we often use those to solve for missing parts. So here's our definitions, and in your notes you'll see 2 blanks. These are the first 2 red lines. So the first one is, a proportion is a name we give to a statement when two ratios are equal. It can be written in 2 ways, either 2 equal fractions or using a colon. A to B is equal to C to D. So if we were to have this A to B, this over here, written as a fraction, it would be A over B equals C over D. A ratio is a relationship between two numbers. It's indicating how many times the first number contains the second. So let's move on now. So we're going to go over our first example now. It says the ratio of faculty members to students at a college is 1-to-5. There are 675 students. How many faculty members are there? So the first thing we want to look at is, what are the key words in this problem? And I noticed that it's got faculty here and it's got students there. So the first thing I'm going to do is put these words in the order they appear in the problem over each other. So I have faculty over students. Then I have this ratio right here, 1 to 15. Now we can set that up as a fraction, 1 over 15. And then if you notice, we have 675 students, and we keep these in the same order. So the faculty on the top and the students on the bottom. The 1 is faculty to every 15 students. So we're going to then set this equal to, we don't know how many faculty members because that's what we're looking for. How many faculty members, right? So that's going to be F over the number of students, which is 675. So in this problem, the way we do this again is we cross multiply. So some of y'all learned this is the butterfly method. That's what this is right here. So we're going to cross multiply. 15F equals 1 times 675. So then we're going to divide 15 into both sides, and 15 goes into 675 45 times. So we have 45 faculty members if we have 675 students. So I need you guys to do this check it out example on your own, and then you can come in and come back and check it to see if you got it right. So go ahead and pause the video. Okay, so if you've done this problem, you should be coming back to me. It says the ratio of games won to lost for a baseball team is 3-2. So again, we're looking at keywords here. We got won there, and we got lost there. So I'm going to do wins over losses. And again, this ratio right here is wins to losses. So that's 3/2. And then it says the team won 18 games. How many did they lose? So we know the team won 18, so we're putting our 18 on top. And we don't know how many losses, so that's L. We're going to put L there, okay? So again, we're going to do our butterfly here. So we've got 3L is equal to 2 times 18. So 3L is equal to 36, and 3 goes into 36 12 times. So L equals 12. So they had 12 losses if they had 18 wins. So those are 12 losses. Now I would like you guys to do these two practice problems, A and B, and then again come back and check with me. So pause the video. Okay, so now you're going to do x times 9 equals 6 times 3. 6 times 3 is 18. And then we're going to divide both sides by 9. That gives us 2. Now I want you guys to notice something here. I can check this by putting the 2 back in and saying that 2/6 is equal to 3/9. And I can cross multiply here. 2 times 9 equals 6 times 3. And 2 times 9 is 18. And 6 times 3 is 18. So we can check this problem by cross multiplying again. So for part B, again, we're going to do the same thing. 6 times x is equal to 12 times 3. 6x equals then 36. 6 into 36 is 6. So again, we can check this. 6 times 6 is 36, right over here. And 12 times 3 is 36 as well. So that's the way you can check these problems. Let's look at the next set with C. Again, we're going to do the same thing here. 3 times x plus 12 and 10 times 6. So 3 times x plus 12, 10 times 6. 3 times x is 3x. 3 times 12 is 36. 10 times 6 is 60. We're going to subtract this 36 from both sides. That gives us 3x equals 24. 3 goes into 24 8 times. And again, we can plug this back up in here to get 3/10 equals 6/20. And so that's going to be 3 times 20 equals 10 times 6. And 3 times 20 equals 60 over here. And 10 times 6 equals 60. Here again, we're going to cross multiply and cross multiply. So we're going to do 30 times x minus 5, and we're going to do 20 times x plus 3. 30 times x is 3x. 30 times -5 is -15. 20 times x is 20x. 20 times 3 is 60. We're going to subtract this 20x over here from the 30x. That's going to give us 10x. We're going to add 150 to this -150 to get rid of it over here. So we're going to add 150 to 60, and that's going to give us 210. 10 into 210 is 21. Then we're going to plug this back up in here again and check it. 21 minus 5 is 16. 16 times 30 is 480. 20 times 21 plus 3, that's 24, is also 480. So that's 480 equals 480. Now we're going to go into section 2 of this unit 6. And I know it says unit 5, but it should be unit 6. Okay, so our objectives are that we can identify similar polygons, and we can apply properties of similar polygons to solve problems. So figures that are similar, and you should notice that this symbol up here is different than any symbol we've used thus far. Has the same shape, but not necessarily the same size. The symbol for similarity is this sideways S. And you should notice that this is similar to the congruent symbol, only it doesn't have the equal sign underneath it. So it's really, sorry about that. Let me see if I can get rid of that. I don't know why this does that when I do that, but whatever. It really is just the top part of that. So now we're going to look at a couple images here. Here we have triangle 1 and triangle 2. You should notice that triangle 1 is just enlarged to get triangle 2, and that these two are similar because they're the same shape but just not the same size. Now over here on the right we have triangle 1 and triangle 3. Triangle 1 is not similar to triangle 3 because they are not the same shape. Looks to me like triangle 1 is probably an isosceles triangle, whereas triangle 3 is a right triangle. So these are not similar because they are not the same shape. So now let's work through this here. So when we talk about the definition of similar polygons, polygons are similar if and only if. Two conditions, guys. First condition, if corresponding angles are congruent. That condition always has to be met for them to be similar. And the second condition is that their corresponding side lengths are proportional. And as we discussed earlier, proportional means that every ratio is the same for every pair of corresponding sides. So the first thing we're going to do is go through this image. So if you guys notice here, angle A up here is a right angle and angle E is a right angle. So that means A is congruent to E. Angle B has one arc here and angle F has one arc. So B is congruent to F. Angle C has two arcs here. G has two arcs here, so those are also congruent. And then we have that D is a right angle here and H is a right angle there. And you should notice that these two images are trapezoids, and that's because we know that side AB and DC are parallel, as well as EF and HG, because A and D are right angles, same side interior angles. Thus, by the converse of same side interior angles, AB is congruent to DC. Same way with the other shape. EF is parallel to HG because E and H are supplementary and they are same side interior angles. And so by the converse of same side interior angles, again, EF is parallel to HG. Just a side note. Okay, now we're going to work through these two shapes. So we could say that this vertical side over here, or the horizontal side over here, AB, is corresponding to EF. Okay, so we're going to put those numbers over each other. First side over the second side, and 6 over 12 reduces to be 1/2. So then we're going to work through the rest of this image as well. What we're looking for is, do we get the same ratio for every pair of sides? So let's move on to the second pair of sides. So we got BC here, and that corresponds to FG. So we're going to do 5.4 over 10.8, and again, that's 1/2. And if you didn't believe me, you could put this in your calculator, divide 5.4 by 10.8, push math in 1, and it will show you that the fraction is 1/2. Let's keep moving through this image. Okay, our next pair of sides are down here. We got CD and HG. So again, we got 4 over 8, and I think we all know that that's 1/2. And our final one, and I'm going to do it in green as well. So this one is green here, AD and EH. So that's 5 over 10. And that too is 1/2. Now I need y'all to notice that all of these ratios are the same. And if all the ratios are the same, and we set them all equal to each other, we call them proportions. And if all the proportions are the same, then the shapes are similar. All right, let's go on to describing these polygons. So what we're looking for in these images first is to see if all the angles are congruent, because that's our first condition. So we should notice up here that Q is congruent with N because they're both right angles. We should also notice that R is congruent to P. Now, the reason why we could say that T is congruent to M is because they are the third angles in two triangles. And if two angles of one triangle are congruent to two angles in another triangle, then the third angles are congruent. So this means that we can say that N is congruent to Q, P is congruent to R, and by the third angles theorem, we can say that M is congruent to T. Now what we're going to do is write a similarity statement. So we're actually going to map these. So we're going to say that triangle, this first triangle over here, QRT, triangle QRT, is similar to NPM. So Q to N, R to P, T to M. Down here, Q to N, R to P, T to M. Then we're going to set up comparing sides. So the first side we're going to look at is QR and NP. So QR is over here. We're going to compare that with NP, which is over here. So we're going to go QR over NP, that's 0.5 over 1, which is 1/2. The next side we're going to look at is RT and MPM. So RT is here and PM is there. So we're going to compare those two sides. RT is 1.1 and PM is 2.2. That also equals 1/2. And our final side is QT and NM, this one right here, okay? So that actually is 1 over 2. Now, the important part of this is that we get the same ratio all 3 times. And because we get the same ratio all 3 times and all the angles are congruent, the two conditions for these shapes to be similar are met. So we can then say that triangle QRT is similar to NPM. So you guys need to go ahead and work this, check it out, and then we'll come back together in a minute after you push play again and go over this problem. So again, we're going to look at these two triangles. We see that B and G are congruent because they're both right angles. You should see that C and H are congruent because they're both 59 degrees. So that means, again, that A is going to be congruent with J because of the third angles theorem. So we're going to do that again. We're going to say all these. We're going to say that B is congruent to G, C is congruent to H, and A is congruent to J. Then we're going to write a similarity statement. And I'm going to say that triangle ABC is congruent with what? A is congruent to J, B is congruent to G, H is congruent. So it should be JGH. Triangle ABC is congruent, similar, not congruent, similar to JGH, okay? Now, once we have this, we can use this to write our similarity statement. So again, we've got AB here maps to JG. So AB is here, JG is here. So we're going to put those two numbers over each other. 10 over 5, that equals 2. Then we're going to compare our next two letters, which are BC and GH. BC is here, GH is here. So again, we're going to put 6 over 3, and that 2 equals 2. And our final comparison is AC, which is this one, is going to compare to HJ, or JH, sorry. So that's 11.6 divided by 5.8, and that is also 2. Again, the important part to notice here is that we have the same ratio all 3 times. We already proved that the triangles were congruent, or the angles in the triangles were congruent. So the two conditions are met again, and so we can say that these two triangles are similar. So the next thing I want to clarify for y'all is a similarity ratio is the ratio of the lengths of the corresponding sides of two similar polygons. When we work these types of problems, this is really important. If I start with triangle ABC over DEF, then I have to maintain that as I work the problem. So all the sides of ABC go on the top and all the sides of DEF go on the bottom. And that's the case here because I have ABC to DEF. Thus I have my 3 here going there and my 6 here going on the bottom. So the top to bottom, and that reduces to be 1/2. Now, if I do it the other way, and I say that triangle DEF to ABC, Then I'm going to put the 6 on top and the 3 on the bottom, and that equals 2. Now you'll see how this applies as we move through the rest of the lesson. Remember that writing a similarity statement is like writing a congruence statement, so we have to be sure that we write the corresponding vertices in the same order. So on this one, 2a, it says identifying similar polygons. Determine whether the polygons are similar. If so, write a similarity ratio and a similarity statement. First of all, these two shapes, it says here on the bottom of this page, are rectangles. So if they are rectangles, the definition of a rectangle is that all 4 angles are right angles. So we know that the first condition is met. Now what we have to do is determine if the second condition is met. Now here's the other thing. If you notice, we only have 2 pairs of sides in this problem. And that's relevant because we know it's a rectangle and opposite sides in a rectangle are congruent. So we only have to do 2 of the sides here. So on this problem, we're going to compare AB to its corresponding side over here, EF. So we're going to put our numbers up here. AB is 6 and EF was 4. Now 6 over 4 reduces to 3 over 2. And I want to remind you that you want to reduce these every time you do them, so that you can accurately compare them. So then we also have this other side, the horizontal side, or the longer side. So this one we have BC, and BC maps to FG. So it's BC over FG. And again, that's 9 over 6. Both of these are can be divided by 3. So this also is 3 over 2. And again, the relevant piece of this is that the 3 over 2 is equal to the 3 over 2. And when that's the case, again, our 2 conditions are met. We have both pairs of sides that produce the same ratio. And our first condition was that all the angles in both polygons are congruent, and that is also the case because they are both rectangles. Okay, for example 2b, it says identify similar polygons. It says determine whether the polygons are similar. If so, write a similarity ratio and a similarity statement. Well, we have this similarity statement that's already up here, PQR and STW. So first of all, the very first thing I notice is that we have a 10 on this side and a 10 on this side. That tells me that this angle is congruent with this angle because it's an isosceles triangle. So I'm going to go ahead and solve for angles P and R. Now, I know that the sum of all the angles inside a triangle are 180 degrees, so I'm going to do 180 minus 36. That's 144. Now, the other thing that I notice over here is that these 2 angles over here are congruent. So I'm going to divide that 144 by 2, and that equals 72. And that means that this angle here is 72, and this angle here is 72. Over here on the right, I'm going to solve for those as well. And you notice that I have arcs over here too because 5, again, is congruent with 5. So that means if this angle here to the left is 62, then the one over here is 62. This too, I'm going to solve for t. So I have these 2 angles that are equal to each other, and 62 times 2 is 124, so 180 minus 124 equals 56. So this angle up here is 56 degrees. Now, right now, I can compare angles in these 2 triangles, and I don't see any angles that are congruent. So my first condition is not met. Now, the reason why it's important to look at this problem, though, is if we start looking at ratios, we've got 10 here and 5, and 10 divided by 5 equals 2. And we got the same thing over here, 10 divided by 5, 10 over 5, and that's 2. Well, first appearance might tell us that it looks like they might be similar because the sides produce the same ratios. However, because the angles are not congruent, we can say right out immediately that these are not similar because the angles are not congruent in these 2 polygons. Once again, I would like you guys to go ahead and try to work this problem on your own and then see if we can figure it out. So pause the video and then come back to me. Okay, so now JLM is similar to NPS. That's what our similarity statement says. But what I want to do first is I want to check to see these angles. So first of all, what angle is M congruent to, you guys? M over here is congruent to N, isn't it? And L, do y'all notice, has one arc, and so does P. And so by the third angles theorem, we can again say that J is congruent with what? S. Does everybody see that? Okay, so now I want to check this similarity statement because I don't know if y'all noticed it, but I don't think J maps to N, does it? Look up here. J has two arcs and N is a right angle. So first thing, this is like an error analysis problem, y'all. So the similarity statement that's on the page right here is not correct. So let's fix that first. So we can keep the first part of this, JLM, and we got to figure out what it's similar to though. So let's look back over here. J has two arcs. So over here, S has two arcs. So we're going to write S. And L has one arc, and over here on the right, P has one arc. And then M has a right angle, and N has a right angle. So that's what we're going to do first, is we're going to write the correct similarity statement. Then we're going to start comparing sides. So we're going to compare JL to SP. So JL is 75. So JL over SP, that's 75 over SP is 30. And both of those are divisible by 15, so that's 5 over 2. Let's compare our next pair of sides. Then we have LM over PN. LM is 60. PN is 24. Both of those are divisible by 12, so that as well is 5 over 2. And our final comparison is JM over SN. JM was 45 and SN was 18. Both of these are divisible by 9, so that's 5 over 2 as well. Again, do we notice that all the ratios are the same and all of the angles were the same? So they met the two conditions again. First, that all the angles were congruent, and then second, that the ratios are the same. So we can say that these two triangles are similar. So now we're going to talk about finding unknown lengths in a similar polygons. Now this time we know that they are similar. So we want to look and see if we can find two sides that correspond that have measures on them. Now we have the left side of this, and one of them has a 3 and the other one has nothing. We have the slanted side, which has 3.6 and nothing. We have the bottom, which has nothing and 9. Does everybody see the top of these two shapes? On the top of these two shapes, we see a 4 and a 6. So those are what we're going to use because those are corresponding sides. So that's 4 over 6. And as I've said before, we're going to reduce this to 2 over 3. And that's going to be the ratio that we're going to use to solve the whole rest of these missing parts. So again, we're going to do 2 over 3. And I want to compare this side over here to the left to LK. So the top over here is 3 and LK goes here. So again, how do we do this? We cross multiply. So that's going to be 2LK equals 3 times 3, which is 9. And we're going to divide 2 into 9, and that's 4.5. So LK equals 4.5. So I'm going to put 4.5 here. Actually, let me erase that so y'all can see it. So that's going to be 4.5 here. We're going to use that 2/3 again for a different side. So now let's compare the slanted side, this side to this side. So again, we've got 2 over 3 equals 3.6, and we don't know this one over here on the right, so that's MN. Cross multiply again, so that's 2MN, and 3 times 3.6 is 10.8. 10.8 divided by 2, MN, equals 5.4. So we're going to put 5.4 over here. Now this third one's a little bit different. It's down here. So we're talking about this side down here and this side over here. So again, we're going to use our 2/3, 2 over 3. This time we don't have GJ, so we're going to put GJ on top. And again, our 9 goes on the bottom. So if you notice in this process, everything from that left shape is going on the top, and everything from the right shape is going on the bottom. So again, we're going to cross multiply. 3GJ equals 2 times 9. So 3GJ equals 18. And 3 goes into 18 6 times. So GJ is equal to 6. So that was this measure over here, 6. Our final problem is perhaps sometimes the most confusing. So what I want you guys to notice first is that we have a little triangle here, and then we also have a big triangle here. So the first thing I'm going to show y'all is that we can relate these to each other with sides. So we're going to talk about the little triangle over the big triangle. That's the first way we're going to talk about this. Okay, so we need to see, do we have any corresponding sides in these two triangles, the little triangle and the big triangle, that have measures? I want y'all to notice down here, we have this 4, right? So that's a side of the little triangle. And then we have this whole side down here. Couldn't we add these two parts together, 4 plus 8, and get 12? So now we have a side of the little triangle that corresponds to a side of the big triangle. That would be 4 over 12, and that reduces to be 1 over 3. Now, if you notice, we can't do that anywhere else, because here we have a 3 and a y, and up here on this one we have an x here, and then we have 10. Now, so this whole side, we do have x here, but then the whole side up here is x plus 10, because we got to add those two parts together to get the whole thing, back to the segment addition postulate. Okay, so now let's see if we can solve for y. So when we're talking about y, we've got the 3 here, and we've got the y over here. So we're going to use our ratio, 1 over 3, and we're going to set that equal to 3 over y. We're going to cross multiply to get our answer. So again, y is equal to 3 times 3. So y is equal to 9. Now, this other part is a little harder only because it's got some variables in it. So again, we're going to use our ratio, 1 over 3. And we've got this part x right here. That's our small side, the side of the small triangle. And its corresponding side is this whole thing. And this whole thing up here is x plus 10. So again, we're going to cross multiply. 3 times x is 3x. And 1 times x plus 10 is x plus 10. Going to subtract x from both sides. That gives us 2x. And that equals 10. So x equals 5. And if you notice, if we put 5 here, 5 plus 10 right there equals 15. And 5 plus 10 here equals 15. So now I want to show you guys some other ways to relate these sides to each other. So now that we have all these measures for all these parts, I'm going to go ahead and erase this and write it back up here again because I want you guys to see some relationships that exist. So we said that this was 5. This whole thing was 15. We said that this whole thing was 12. And we said that this side over here was 9. Now the relationships that I'm about to show you that we can use only exist on the sides where we have parallel sides of little triangle and big triangle, okay? So I'm going to go ahead and erase this so I can show you guys some of these relationships. So first thing I want you guys to see is that we could take this 5 and put it over this 10. 5 over 10, and then the sides down here, 4 over 8. So 5 over 10 equals 4 over 8. We know that's true because 5 over 10 equals 1/2, and so does 4 over 8. That's one of the relationships that we could use. So now I want to show you another one. We could also do 5 over 15. 5 over 15. That equals 4 over 12. 4 over 12. 5 goes into 15 3 times, so that's 1/3, and 4 goes into 12 3 times, so that's 12. I mean, that's, yeah, 1/3. All right, so I got one more I want to show you. 10 over 15. 10 over 15. That is equal to 8 over 12. 8 over 12. So again, 5 goes in here, so this would be 2/3 equals, and 4 goes in over there, 2/3. So what I'm trying to show you guys is that there's a relationship here, over here, or each of those parts over the whole. All of these relationships can help me solve for missing parts. Now, what I just showed you does not relate to these end pieces here. So if you notice, that relationship did not exist between the 3 and the 9. It only worked on these sides over here, this side and this side, that were not the parallel sides. Again, I told you all these were parallel. So hopefully that helps y'all.